Hello everyone, so this is Dipesh Mishra and we going to discuss for this session over artificial neural network. Okay, so let me first tell you the objectives of this session. At the end of this session, we're going to discuss about and we'll be accomplishing the artificial neural network, how does it work, and how artificial neural network and their different patterns linearly effectively. We're going to discuss about the backpropagation algorithm, and we're going to discuss about the different perceptron and their multi-layer perceptron and the implementation in the Python programming. So that's all the objective for this session. Now let me start with the introduction of neural network. Okay, so my friends, let me tell you, the idea of artificial neural network is on the belief that working of a human brain by making the right connection can be limited using silicon and wires and living neurons and their dendrites. So like our human brains works on a different biological neural network structure, and that's how we do react or act. We has to understand about the human brain is composed of 86 so there are 86 billions nerve cells, and these nerve cells are called neurons. Basically they are connected to other 1000 cells, and these 1000 cells are called by axons. These are axons, and the stimuli for external environment or inputs from sensory organs are accepted by the dendrites of this neural network. So these inputs basically create electrical impulse which quickly travel through the neural network, and a neuron can send the message to other neuron to handle the issue or does not send it forward. So let me tell you few structure that how does it work basically. So for that we need to understand about so let me tell you so let's suppose to tell you, so we all must be aware of this reflex action part. So how does this reflex action actually work? If you must be aware of this pretty environment, that how we actually respond, and the response system of our mechanism is, let's suppose there is a hot cup and we touch it. So at the same time our skins let us know this is a hot cup, and this is our hand. How does it work? So this is a brain. Okay, so basically there are a lot of nerve cells, and these all nerve cells are actually connected from their different dendrites and different cells, and it goes to the central nervous system, CNS, and first it sends the data and then comes at with after the reaction. So it let us know so that hot. Okay, and then again the nerve cells got in action, and our brain tells keep aside your hand, keep aside. So that's how our brain works with the structure of with the network of these nerve cells. So there are billions, 8 billions, as I told you. There are 86 billions nerve cells connected. Okay, so 86 billions nerve cells are already connected, and they are going through with a certain rules and process, and these generalization is comes in a particular training set. So what actually we are doing this neural network sets, so there are a lot of structures are defined, and the same process we do given to our algorithm so that they can come to know how to process a particular paradigm and process of doing things. Now, if we more discuss about a part, so let me tell you about neural networks, how basically neural networks learn from example. So let's suppose in a very general term, let me tell you, let's suppose when a small child and like when a small child and it's while it's growing, we let them know to a small child how a function of our brain works under a circumstances. So let's suppose in this environment, if it's so hot, so we required to on the fan, okay, or we take in general data sets of to recognize a number. So I'll be going to discuss about how we can recognize a number with this neural network process. So yeah, how neural networks learn from their examples. Let's suppose I need to recognize 7. Okay, so to recognize 7, there are a lot of things that we are and our nerve cells actually redefined the structure and process the lot of things. So in the very general data sets, how neural networks learn from the example. So how do we do numbers? How do we learn numbers? That is from 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So these are the basic numbers we are having. Okay. Now, if I has to tell you how do we write 7, so I'll learn from few examples. So the examples of networks is, first of all, this is 1, and then again I'll take some examples, that is 2, okay, and sorry. So let's suppose this is our network. Now, so network would be, what was the network? That is 1 and this is 2. Now, on either network we are going to create, that is 1 and this part. This is okay, sorry. So we got another number here. So my dear friend, what we are doing, we are learning from different examples. We are learning from predefined data sets. We are learning from our already given example. Okay. So if it is not okay with you, I'll take one more example of it. So how do we recognize a particular data set of recognizing a dog, a cat, or an animal, or human being, anything else? So let me show you. Okay, so I'll take an example of a cat and a dog. Okay, so let's suppose, oh sorry, one teddy bear I'll take here. So this is a teddy bear. This is a teddy bear, and this is in a cat. Sorry. Okay, so what is basically happening? So we have a two structure. One is teddy bear and one is a cat. Now, how we can how we can recognize whether this is a teddy bear and this is a cat? So we have some different recognizing pattern, and this recognizing pattern is this ear, and the different structure of this ear and this ear, and we have this general neural sets of this nose, this eyes here with it. Okay, so we have different neural network structure. Now let me define some predefined process that how we recognize a new teddy bear or a new structure. So this new structure look like in this terminology. I hope so. You can recognize it's very similar to a teddy bear, we can say, or a little bit similar to a cat. But if we have to define or negotiate that, so the most valuable thing will be going to do that. That is how much similar to which structure. So that is a part of our understanding that how it's going to be work and how it's going to be evolved. Okay. Now that was a very small example I've been taken. So yeah. Yeah. So as we have some a generalized process of doing this all the thing. So while we are while we are doing neural networks in the terms and process of with delivering some algorithm, so we does not require any description or we does not require any programming process because it's whole a network that we're going to create. Basically, neural network adapts different training process, and the similar problems can be solved with the similar training neural network sets. Okay. Let me tell you some different application of neural network. So there are a lot of application, like we have some classification examples and some recognition and identification examples. So let's suppose in classification the problems was in marketing. So how do we use in the these problems in marketing on the base of the consumer spending different classified products and how much they are spending in which particular product, so we can classify in the terms of marketing. Okay, now in defense, radar and sonar image clarification we do, in agriculture and fishing, fruit and catch grading we do, in medicine, ultrasound and electrocardiogram and image classification and electroencephalography medical diagnosis we do. Well, in the recognizing and identification, when very general computing, the telecommunication, speech, vision, and handwriting recognition we do define. So this is one of the pattern that we do follow in recognizing way. In finance, signature verification and bank note verification we do. So what does like there are a lot of algorithm nowadays so that it easily understand whether this particular signature is signifies for this particular person or not. So we do use this same algorithm of neural network, and accordingly we do define. So this is the part of neural network that we do follow, and that's how do we proceed. Yeah, so like we were discussing about the application of neural network. So here, like some assessment and forecasting prediction also in the part of this neural network only. So like in engineering, product inspection, monitoring and control we do, and some for in defense, like while the the captain is targeting any tracking any particular target, so he use neural network process so that weapons can be accommodated accordingly. Security, a lot of issues of security by the use of the neural network, like fingerprint matching, surveillance, motion detection. These are the part of application. And now let's talk about some forecasting and prediction in this part of this neural network. So the few major process that by the neural network been define, and accordingly we do predict in finance, agriculture, marketing, and metrology. So let's suppose in finance, basically foreign exchange rate, stock market forecasting usually used to be happen with the use of artificial neural network, with the use of some predefined data sets available. And let me tell you one new innovation happens in India. Like one of the company in Bangalore, they have started one company, and they are providing loans to the farmer. And let's suppose how they are actually providing loans. So like they actually use this artificial neural network algorithm over the different lands, and accordingly they are like providing loans that in this land how much crop it will yield in the next year or the upcoming growing season. In marketing, by the generally neural network, we can predict the sales. Metrology, weather prediction happens with the use of this artificial neural network. So there are a lot of applications, and like we can use for a lot of applications. Now we're going to discuss some brief, and not some brief, it's about we're going to discuss the how this artificial neural network work. Before that, we're going to discuss about how this biological neurons actually works, because artificial neural network is a synonym of this process of our neurons works accordingly. So let me introduce neuron. What is this neuron? So this is the whole diagram of this neuron, and here we can see this is the dendrite part. This is the whole axon, and these are the dendrites. These are the different dendrites, and and these are the terminal buttons. Okay, this one is the nucleus, and this is the whole body of this nerve cell. So as I told you one previous example of how reflex action work, so what exactly happened? There are a lot of chain of nerve cells. So one nerve cells is being connected with some dendrites to the terminal buttons, this axon part, and this one is actually connected with some different nerve cell. These are different nerve cells going to be connected, and then again it's going to be like that, and then again so and so, and again it's going to be connected similarly. So what is exactly happen? Like lot of nerve cells is going to be connected with each and every terminal buttons and with their dendrites. Now what basically happens, let's suppose if any data is going to be transferred from our body to our brain, or from brain to our body. So basically while in the nerve cells the data being transferred, so there would be some ionic changes happens. So what's happened? There's some ionic changes, okay, plus minus any ionic changes would be happen. Now how these ionic changes can be identified and processed in the further, so that we can understand how these neural networks work. So we'll be going to discuss similarly. So what is happening? So when some ionic changes happens from axon to dendrite, from this axon to dendrite, so there is basically one synaptic gap. So this gap from there to here, this is called synaptic gap, as it mentioned clearly here. So this is the synaptic gap, and this is the terminal button, as I already in the previous images it has been mentioned. Now what is happening when the data is being transferred? Basically from the synaptic gap to the dendrite, this one is the neurotransmitter is actually taken place. This neurotransmitter sends from this dendrite, from this synaptic gap to dendrite, and that's how the data being transferred from one nerve cells to the another nerve cells to the another nerve cell to the another nerve cells. So that's how the process happens. So it's a long process, and accordingly the artificial neural network we also going to illustrate in the use of this one. So what is basically happen with this one, like nature of neuron we use similarly as the mathematical neuron or node in artificial neural network, and the issue is like a neuron can send the message to the another neuron to handle the issue and or does not send it forward towards. Yeah, so this one is the whole diagram. Yeah, so let me show you how the nerve cells taken places, how it's sending the data. Sorry. So how it's sending the data from yes. So I hope you got how the sensation and how the data is being transferred in a form of electrical activity. Now let me tell you some ANN basics, and this one is like there are two fundamental components in biological neural network, that was neurons and synapses. And similarly in artificial neural network we have again two major fundamental offsets, and these are nodes and weights. So here, like in artificial neural network, what we are using, like neurons will be replaced as nodes and synapses would be as weight. So let's suppose there are different nerve cells. This one is a nerve cell, okay, and again this one going to be the nerve cell, this one is the nerve cell, and this one again nerve cell, this one again nerve cell, this one again. So how it's going to be connected? So by the use of weight, it's going to be connected. Yeah, so like weight is the format by which it will accumulate and the data is being transferred. This is the process and this is the way we use in artificial neural network. Okay, so basically there are some input and output process happen within the nodes with the use of similar neuron and with the use of this weight part. Okay, so what and how we can process with this one is how neurons and nodes can be differentiated. Neurons are in our brain, nodes in artificial neural network we're going to discuss, and how and it taken places is there are some input part in this node. If you are visible, this one is the input part, okay, and these are the input ports, and now this one is a node. So what this node would be is a sum plus squash. Now let me define you, and then we got the output. What is this sum and squash? That yeah, so I was talking about squashing. So while in squashing, what we do, like whatever the inputs we are having, so we use some summation and inputs form, and then we process in a certain notification, and we later on we got the output. Okay, so yeah, so this one is the structure of node. So in this node it's clearly mentioned here, like when we got an input from different nodes. Let's suppose this one is a node, this one is a node, this one also a node. So throughout some weight we got an output. Okay, so we will put here any formulation that let us know that how it will recognize with their certain neural networks, and that's how we'll be getting the output accordingly. Yeah, now what is happening when there is any kind of node, and when node is going to hit the activation barrier. So activation barrier is, let's suppose I would like to do this work. Let's suppose I need to go outside for a function or for a party. Okay, so there are a lot of parameter depends whether I will go this party or not, and it will depend. Let's suppose what is the weather outside, what are the conditions. So what is happening over there? So there would be some certain parameters on which I will either go or not. Okay, so the parameter on which I will go, the extreme parameter is called our activation barrier. Similarly, in any chemical composition, when a chemical reacts with another chemical, so there are some there is some activation, like activation afterwards. The chemical reacts towards the another chemical. So that's what. So this one is the activation function. It's here. So what is happening here throughout the activation barrier, from this particular node, that is 5.0, to the output where the it's going to be either work or not, either the node will like hit the ejaculation or not. So that what is the part of our activation. So this one is the whole squashing of our node of output. Yeah. So now we can make a differentiate between synapses versus wake. So as clearly mentioned, this is the biological nerve cell. So in this biological nerve cell, the axon and the synapses is over some the end of the dendrites, and then again it will be again associate with another dendrite. Okay. Now as I told you, there would be some synaptic gap. This one is a synaptic gap, and in the synaptic gap there are some neurotransmitter. Yeah, and the same process evolved in our artificial neural network. So this one is our node, and this one is a weight. Weight is also called as synapse, and then whatever the release amount of data going to be sent from one node to the another node throughout the process, and there are some potential towards it. So there is like 3.0 like output we are having from this particular node. Yeah. So there are different elements of neural network, as I told you. So what's happened when there are different nodes, so in different nodes, when, as I told you, when we are doing squashing, so squashing depends on different formulation, like sigmoid function, the activation function we are using, it depends on that particular also at the summation of all the nodes coming out from the data. So here we have the function called fx, and this signifies psi x, and the formulation is 1 upon 1 plus exponential power minus x. So this is the function that we are having, and once we go through with this function, we are fetching the data throughout the function, and then the output comes. Yeah. So as clearly mentioned, here we have the output coming out from the different nodes, that is P1, P2, P3, and we have different weights called W1, W2, W3, and the function, the summation of all the data, that is called squashing, and we are getting output here. The output here is A. Okay. So in the later on session, I will let you know that how do we work with some real life example. So I have a very interesting example for you, because we'll be taking one beer example, and in which it let us know about, because I think you all are interested of beer, so I'll be talking about more over it. Yes, so there is clearly mentioned that how this function is going to be worked. So let me first clear this. Yeah. So what is happening? Like the function here is that the output we are having is A, and it depends on the function, the total function, and the function depends on this particular input and the weight of this particular input coming out. So this one is the node, and the synapses here is the weight. Okay, so the weight here is that P1 W1 plus P2 W2 plus P3 W3 plus B. So as clearly mentioned, B is the additional output that we can extract. This is called also bias. So this B also called as bias. So this is the bias which is provoking the whole function with their output barrier. So when the activation function happens throughout the whole data, so activation being deployed here, and as similarly we got the output with this activation barrier. So the total output will be getting here is function, the summation of pi. So we'll be abstracting here pi plus this bias. Yeah. So the neural computing requires a number of neurons to be connected together into a neural network, and there would be some arranged layers. So I hope it's clear. Yes. Yeah, as I told you already, what is activation function? Basically, activation function is a non-linear because it depends on the threshold level. So when the threshold level is going to be up from the input nodes, then only the node will react with as an output. So activation barrier works on the different perceptron. So I'll let you know what are perceptron and how we can propagate this perceptron and how we can interrelate with this perceptron also. So what is happening here? Linear functions are limited because the output is simply proportional to the input. So that's what I let you know, that how it is proportionally defined with the activation function. And like there are different activation function also. So I'll let you know about different functions, activation function, in which majorly I'll let you know three major function, and these three major function is so these three major activation function are: first one is step function, another one is sine function, and the another one again is sigmoid function. So like this one is here, like this one is a sigmoid function. So what is happening in this sigmoid function is, like, we have an output that is totally non-linear and is above to the x-axis. So in this plane, sorry, this one is a step function, and this plane, this one is the stack function, and this sigmoid function is propagating from the whole over the 360 degree, in which from the 180 degree to this particular axis of x. So it's come out from here, and yeah, so this one is a sigmoid function, and then again this is the radial base function. Radial base function make a graph like this. Okay, so this one indicate radial function, this one is a sigmoid function. Then again we have step function that I was talking about. So this one is the step function. Step function look like that. Yeah, this one is a step function. Then again I let you know about some sine function. So sine function having axis in xy plane and xz plane also. Yeah, this one is the sine function. Sigmoid I already told you. So basically these are the activation function that works when we have some threshold level. Okay, so if it's not clear, I'll let you know with an example. I hope it will be more clear with this example also. Yeah. So there are linear transfer function also, symmetric hard limit transcription function. So basically there are different activation function, and the different activation function, it depends on the different perceptron. Okay, so different perceptron and the feature of this perceptron, either we are doing back propagation, either we are doing feed forward. So different algorithm having different perceptron process, and that's how we do use different activation function also. Yeah. So as I was talking about, see what is happening right now. Till now we discussed about how the network works, how the nerve cells or how the nodes and the synapses going to make an interlink, and how the network is going to be processed further, and that's how we actually indicate with different perceptron process. Now we let you know about the different architecture of this layers, like when the different neurons is going to be connected together, and how it will process and how it will other linked and get us a learning algorithm process, so that we can train our algorithm, so that we can train our process to make it follow. So that's what we're going to discuss. So there are different network architecture. There are a lot of architecture in which I'll let you know the three major architecture, and these are single layer feed forward, another one is multi-layer feed forward, and the third one is the recurrent. Okay, so these are the major three architecture that we're going to discuss. And like basically what is happening with these structure, with these process of structure, we do either train our algorithm or train our like our perceptron, so that it will either make us follow for a particular example, or either gives a suitable current position of our nodes, and let us know whether it should be go in a which direction. Okay, so like let's suppose we talking about first single layer feed forward neuron. So what is happening in this single layer feed forward? So if you can see, there are different input layers. Okay, so this one is the different input layers. Okay, and these are the different nodes. Okay, so what is happening before to telling these three things? So what is happening, there are three major process and three major layers we are having, and the three major layers are, first one is input layer, input, another one is hidden layer, hidden, and another one is output. Okay, so these are the major layers we are having. Okay, now while we are talking, some arrangement of these layer make us the different architecture, and the different architecture will let us know whether it is single layer feed forward, whether it is like double layer feed forward, or whether it is recurrent. Okay, these architecture will let us know that how we'll be processing. So input, this one is the input layer, and either we having the hidden layer, and then again we have the output layer. Okay, so now what we're going to discuss, how this one is a single, or you can say the processing with the same input and output, but there is one structure called hidden. Now when we make an arrangement between input and output with the use of this hidden layer, that let us know that how we are processing the thing. Okay, so I was talking about single layer feed forward. So the functions and everything is mentioned. So let me tell you how this function actually works with some squashing, and how we can put some sigmoid function under it, so we can get some activation barrier, and after the activation how we can get the output. Okay, so let me tell you over the notepad. Okay, so yes, we have, let's suppose we have here three nodes, and these nodes are called x1, x2 and x3. Okay, now then again we have this w1, w2 and this w3. This is the weight over it, these nodes. Now let me tell you about how we can make some function with it, and the function, as I told you already, so the squashing we are going to do that with these three nodes. This is the node, and okay, and as I told you, we has to do bias of it. So this one going to be the bias. Yeah, summation. And now after the function, we need to put its activation function, activation barrier here, and this one we are going to use for this one is sigmoid. So we're going to use sigmoid. This one is a sigmoid function with it. And we got the output. Yeah. So this one is the total function. Now, I hope the function is clear. So we'll be doing the same thing with an example. So the example I'm going to take, that is from your nearest outdoor, from your nearest home, there is a beer party, and you wish to go over there. So we'll be doing the same implementation of this single feed forward with this process, that how the single layer perceptron would let us know whether you should go for that party or not. Okay, so we have three major parameters that indicate us that we should go for that party or not, and these parameters are: the first parameter is weather. What is the weather outside? Okay. The second parameter is whether your wife is allow you to go over there or not. Okay, or either whether your wife is going with you or not. Okay, so the second parameter is your wife. Okay, and the third parameter is vehicle. Like when you wish to go over there, you would have a vehicle or not. Okay, so let me tell you with some function, and this function would be yeah. Okay, so this one is the beer mug. This is the beer mug. Now we have three parameters. The first parameter x1 will be taking this node, and this parameter is this parameter is x1 we're going to discuss, and this parameter we used to say weather outside. Okay, now another parameter x2 is your wife, and then another parameter x3 is vehicle. Okay, so what we're going to do, that see, we're going to eliminate first which parameter will decide. So this parameter, if any parameter will decide you should go outside or not, is called as your activation function. Because let's suppose you wish to go outside, the first parameter that decide you should go, that is the weather. If there is a heavy rain or something like that, you cannot go. Okay, but the second parameter, when we'll say whether your wife is going to be with you or not, so this doesn't matter that much. Okay, so with this without this parameter, you can go outside. Okay, and the third important factor is traveling. Okay, let's suppose you have car with you. So these are the three parameters, and let's say we're going to put some numbers with it, data sets, and this number is like 5 this parameter I'm going to take 6 number, and this parameter I'm going to take 2 number, and this one is 3. Okay, so if you can see, like we're going to take one activation number. Activation one is activation is 5. So if the node will decide whether we should go outside or not, with this function, with the activation barrier is 5 number. So if 5 going to be greater than, if this activation function is greater than this output, okay, then we can go outside. otherwise we will not. So what we are doing, so if we wish to go outside, this parameter decide that we has to go, then again this parameter decide, this is the weight, this used to call as weight. So this does not decide that much. Okay, then again we have that we right now we're not taking traveling. Let's suppose you have car, so again we are getting 0 from this traveling and this your wife part. Okay, and the 1 from this node called your weather outside. So what is the function? As I told you already, so whatever the function we are having is, the function is function x1 is your x1 w1 plus x2 w2 plus x3 w3, and we put the output, that is x1 is here we are having 6 and the weight is 1 plus x2 is again going to be negligible. So the negligible output would be, the negligible output here is 2 and 0 plus 3 0. So this one is the total output we are having, and this output we going to have is this output is 6. So the activation barrier, the 6 number is greater than this 5. So according to the single layer perceptron, that I am going to that party. So this is the total node notification, or you can say squashing we are doing, which let us know whether I should go or not. So that is the process that we do follow, this nodes and all, and I hope it's clear with you.